the next problem, that is problem number 44. I've already written on board and I'll read it for you before starting the problem. This problem says the 6-digit number 5A, 4B, 6C is divided by 7, 11 and 13. Find the value of that. The first part is that you have to find the value of A, B and C. Then after putting the value, I'll easily get the second part. So any number, if it is divisible by any numbers, is 7, 11, 13, so that number must be divisible by their LCM. This is very clear concept for everyone. So now for this 7, 11 and 13, all three are prime numbers, so no need of doing LCM. So directly I can multiply to get the LCM of this. So this will come around 91 into 11, 1001. So now something is very special for this number is that if I getting a 6-digit number by multiplying 101 with some number, that will be something like that. Let's say I'm multiplying ABC with 101. So how will it act? It will act like ABC multiplied by 1000 plus 1 multiplied by ABC. I am just distributing the number as because this is nothing but 1000 plus 1. So I am just showing the speciality of this number, this 1001. So what I will get here, I will get ABC and then a number followed by 000 plus ABC. Okay. Now if I add this ABC will come here. So this number will change by repeating the number again. So for any 3-digit number multiplying with 101, if I get any 6-digit number, the number characteristic will be that the first 3 digit will be repeated for the last 3 digit. So similarly, if this is can be divisible by 1001, as because these are the LCM of these 3 number given, which is divisible to this number, then I can say the number must be repeated in nature. The digits up to the first has to be repeated in nature for the last 3 digit. Now from the similarity, I can say that B should be this, and then this should be this, and A should be this. From this I can say that A is 6 and B is equal to 5 and C is equal to 4. Now if it is the case, then what is the value of 3A minus 5B plus 7C? It will be 3 into 6 minus 5 into 5 plus 7 into 4. So this is 18 minus 25 plus 28. This is 46 minus 21, that will give you 21. So this will be your answer for this. Moving to next, the number 45. So 45 says if a 9-digit number, if a 9-digit number, the number is given like that: 7, 8, 9, x, 6, 3, 7, 8, y is divisible by 72. This is 72. Then find then the value of x plus y. So to find the value of x plus y. Now starting with as because this number is divisible by 72, so let's see, 72 I can get by this numbers 2 into 2 into 2 into 3 into 3. So that means this number, if it is 72, if it is dividing perfectly, means this number is perfectly divisible by 72, then this number must be divisible by 2 and 3 as a prime number. So from that concept, I can say if any number is divisible by 2, so then the last digit must be what? 0, 2, 4, 6, 8. This must be in the last position. And if that is divisible by 3, then sum of all the number must be divisible by 3. So let me see. 7 plus 8 is equal to 15 plus 9, 24, 24, 6, 30, 30 plus 33 plus 7, 47, 47, 33 plus 7, 40, 40 plus 8, 48. So 48, and the remaining is x plus y. This must be divisible by 3. Now 40 is divisible by 3. So I will get, so this must be divisible by 3. So the minimum that x plus y has to be 3 to divisible by 3. So now if x plus y has to be some multiple of 3, then what are the values that holds good? Now y, I can say if x plus y is equal to 3 at least, so y could be 2 and x could be 1. Okay, or otherwise if it is in all together, it is needed that x plus y will be the, what will be the value. So x plus y, the minimum value must be, x plus y minimum value has to be 3 to be divisible by 3. So this could be your answer. So and this also lies good. X plus y can be 3 and x individually can be said to be 1 plus 2, and 2 is if 2 is there in the y place, then it is divisible by 2. This also holds good. So you can say the number has to be divisible by 72 if in that case that x plus y is equal to 3. This is the requirement of the problem. Moving to the next problem, that is 46. Says let x is equal to 433 to the power 24 minus 377 38 44. What is the unit digit of x? Okay, now this number of any number having a multiple of power has a specific concept. That concept is that the unit place, one or the other, or you can say the in first term, second term, third term, or fourth term, in any after some of the terms, the unit place repeats itself. So I will take some example to understand. If I consider this one and concentrate on the unit place only, so 3, if I multiply 2 of this number, the unit place will be multiplied with the unit place, and that will be kept at unit place only. Okay, it will not be affected by the other numbers. So 3 at the unit place, when it will multiply another such number which is having the same unit place, I will get 9 at unit place. Then after this 9 in unit place, if another number with this multiplied, I will get 7 in unit place. Then I followed the same rule for the unit place, I will get 21, and I will follow the same rule with again I will get 3 in unit place. So after 4 of the step, I will get back the unit place as 3. Then after the circle will move in the same way. After every 4 I will get 3 back. So if I see for how many numbers this has to be happen, 4 3 4 times consecutively 4 33, I have to multiply to get 3 back. So this will consume 4 of 33. So the power says if it is 24, then after 4 of each cycle I am getting back. So how many size cycle? 6. Now see, this is perfectly divisible by 4 and there is no remainder. So that means I will get 3 at the end of when it is consumed or 24. So my last digit for this case will be, I will write it just like last digit is 3 for first term. And similarly if I calculate for the others, let's see what we will get. I will get for 7 into 7 49, 9 into 7 63, 3 into 7 21, 1 into 7 7. Then in this case also after 4 I am getting back 7 again. So if I try to get how many such terms cycle will be completed, here 38 by 4 it is 9 times the full. This will be quotient and this will be quotient, and thereafter 2 will be remainder. So 2 will not be considered as it is not multiple of 4. So 2 means last I am getting 7, then after 7 into 7 49, because remaining 2 how will you use 49, then 9 into another 7, which is this is the remaining I am talking about. Last I have got up to 7, then remaining 2 which will contain 7 in the unit place, 7 that will turn into 9, then another 7 will turn it to 3. So the last digit for this also, for this case will be 3, and for this how little 6 into 6 36. That means 6 is not changing. So every time I will get 6 at the last place. So last place for this is also I will get 6. Now if I do this, the last place, what is the last place for this? If I calculate even all the digits, if I calculate, this is last place with 3, this is last place with the minus, because this will be totally minus, so I have to cancel it out. 3 will nullify 3, so it will be 0, and only the last term for this is 6, so 6 will remain. So last term for overall sum will be 6 here. I think I make you understand good. So this way you have to calculate, because here it is not changing, so 6 will be 6. So whatever the power, I will get 6 at the last place. So for the first two case, I will get 3 at last place, 3 for this, but when it will deduct, because the sign is coming minus here, so it will deduct each other, so it will cancel out. Only the remaining is, this will be affected by this, so it will be like that. Okay. So this is up to now. The next class I will move on to 47.